everyone, welcome to the second lecture of strength of material. So in the last lecture we have discussed about the basic terminology of stress and strain. So in this video we are going to start with the term elasticity and elastic limits. So what do you mean by elasticity? Elasticity is the property by virtue of which certain materials return back to their original position after the removal of the external force is called elasticity. So suppose I am taking the example of this duster. You can assume it as a rubber. So rubber is very elastic material. So you apply the tension load, it will increase the length of the rubber. But the time when you remove the load, it will come back to its original position. Suppose I am drawing a figure here. This is the original length of this rubber sample and you applied a tensile load P to this rubber. So due to this tensile load, there will be some elongation of this rubber and its final length will become L plus delta L, where delta L is the elongation in our rubber sample. So what do you mean by elasticity? But the moment when you remove this load P, it will come back to its original position. This is the meaning of elasticity. I am going to repeat here that once you applied a tensile load P, it will increase the length of the sample. The moment when you remove the load, it will come back to its initial position. If the final length and original length means the initial length of the rubber sample was L and after the removal of the load its length become L, then the material is called as elastic material. So I hope you understand this concept. Now we will move further to the elastic limit. So what do you mean by elastic limit? The body will regain its previous shape and size only when the deformation caused by the external force is within a certain limit. The value of stress corresponding to this limiting force is known as the elastic limit of the material. So how you are going to understand this? Let me draw a diagram first. This was our sample of initial length L and we applied a tensile load P on this sample. And the final length of this sample became L plus delta L. Delta L is the elongation. But the moment when you remove this load, it will come back to its initial position. Initial length was L and final length is also L. But it will holds good only when you apply this load up to a limiting value. Suppose this limiting value is P node. It will holds good if the applied load P is less than the limiting value P node. The moment when the applied load exceeds the value of P node, there will be some permanent deformation in the body. Now consider the case when the applied load P is more than the limiting value of the stress. In this case, what will happen? The load P we have applied here, L is the original length. Here P is the load which is more than the limiting value. So in that case, the load P is acting here. Due to this load P, the length will be increased by delta L amount. The moment when you remove this load P, there will be some elongation. There will be some elongation left. That is delta L dash. The initial length of the body was L, but the final length of the body is not L. There is some permanent deformation in the body. This is called as permanent deformation. Permanent deformation. And this load, this limiting load or limiting stress up to which the body behaves elastically, it is called as the elastic limit. So what do you mean by elastic limit? Elastic limit is the limit of a force or stress up to which or application of which the elongation will occur, and the moment when you remove this load, the body will come in original shape as before. So we have taken two examples here. In the first case, the load was less than the limiting value. So the our body comes into the original shape or the initial shape. But in the second case, when our load is more than the limiting value, the initial length of the body was L, but there is some deformation which is left after the removal of load. This is termed as permanent deformation. So now we will start with the Hooke's law and elastic moduli. So we will look at the statement that what was the statement of the Hooke's law state that when a material is loaded within the elastic limit, the stress is proportional to the strength produced by the stress. So what does it mean? The first important things in this statement is the elastic limit. This is the question simply asked in many of the exams, that Hooke's law is valid up to which? Up to elastic limit. So Hooke's law is always valid up to the elastic limit only, and the elastic limit we have already discussed. So Hooke's law is valid up to the elastic limit, and it states that the stress is proportional to the strength produced by the stress. The stress can be normal stress or shear stress, but whatever stress is acting on the body, the strength produced by that stress is proportional to the strength. What does it mean? This means the ratio of the stress to the corresponding strength is a constant within the elastic limit. This constant is known as the modulus of elasticity or modulus of rigidity. So it states that if a body is loaded within the elastic limit, the value of stress divided by the strength, means the ratio of stress divided by the strength will remain constant for a body, and this constant is known as the modulus of elasticity or modulus of rigidity. Now we will further discuss about these two, that how these two are different. The first one is modulus of elasticity. Modulus of elasticity is sometimes known as Young's modulus of elasticity, and it is denoted by E. E stands for elasticity, and it is equal to sigma upon epsilon, where sigma is normal stress and epsilon is normal strain. Sigma is normal stress and epsilon is normal strain. The stress can be of two types. It can be compressive or tensile. So sigma is compressive or tensile stress, and epsilon is compressive and tensile strain. The second one is modulus of rigidity, or it is also termed as the shear modulus, and it is denoted by C, G or N. It can be denoted as C, it can also be denoted as G or N, and it is the ratio of shear stress tau to the shear strength phi. So our modulus of rigidity is the ratio of shear stress tau to the shear strength phi. The shear stress and shear strength we have already discussed. Now we will start discussion with the factor of safety. So factor of safety is the ratio of ultimate stress to the permissible stress. So what do you mean by ultimate stress? Ultimate stress is the stress level at which the material fails. So at this stress level, ultimate stress, our material will fail. So factor of safety give assurance for the safety. Why? Because we are permitting the stress level below the ultimate stress. Suppose the ultimate stress of the material is 450 MPa. This is the stress level at which the material fails. The permissible stress, it is also called as allowable stress, is the stress level up to which we allow the stress in the material. It is 150 MPa. Then our factor of safety will be, comes out 450 divided by 150 is equal to 3. Means, what does it mean? That our permissible stress is 3 times lesser than the ultimate stress, because our material can bear the stress level of 450. But to be on the safe side, we are not allowing the complete stress, and we are allowing some part of it up to 150 MPa in the material. So the factor of safety will come out to be 3. Now we will start discussion with the constitutive relationship between the stress and the strain for 1D stress system. In 1D stress system, we are considering one direction only. So we are interested in x direction only. Suppose this is our sample and we are applying a load P. Cross-sectional area of this member is A. Initial length of the member was L, but due to application of this load P, the change in length is delta L. Now we studied about the Hooke's law. Hooke's law states that the stress is directly proportional to the strain. And when this proportional sign will obsolete and we use the equal sign, a constant of proportionality will come into picture, that is known as modulus of elasticity. The strain value in this member can be written as the stress divided by modulus of elasticity. So strain is this member is equal to the ratio of stress to the modulus of elasticity. The strain can be defined as the change in length divided by original length, which we have discussed earlier, and the value of stress is equal to the load divided by the area. Now we are going to start discussing with the 2D stress system. So before starting the 2D stress system, there are 3 terminology we need to study first. The first one is longitudinal stress, other one is lateral strain, and the last one is the Poisson's ratio. So we are going to take an example. Suppose this is the initial position of the bar. The initial dimension was L and the cross-sectional area was B was the width and D was the depth. This is the cross-sectional area. We are going to apply the load P now. Due to action of this load P, the length will increase by del n amount. Simultaneously, the length will increase in x direction, but the cross-sectional area B and D is going to reduce by some amount. What I mean to say, that if there is some elongation, if there is increase in the length in one direction, then there will be decrease in the length or cross-sectional area of the member. So if length is going to increase, then the cross-sectional area will reduce. So the final cross-section area of this member is going to be B minus delta B. It will reduce by del B amount, and the depth of this cross-section is going to reduce by del B amount. So in case longitudinal strain means the strain in the direction of length the change in length is del L divided by the original length. The second one is lateral strain. Lateral strain are the strain produced in the perpendicular direction of the longitudinal. So these are the length and the perpendicular direction is in the direction of B and D, means in the plane of cross section area. So for lateral strain, what we are going to do, we are going to use the dimension of the cross section, because this cross section is perpendicular to the direction of the load. So these are the lateral strain. So lateral strain will be 2. One is for the width. The width is going to reduce the value del B divided by the B, or we can use the depth. For this direction, both these two are lateral direction. The L is longitudinal direction, B and D are lateral direction. So del B by B or del D by D, both are lateral strain. Now we are going to start with the Poisson's ratio. So what is Poisson's ratio? Poisson's ratio is denoted by mu, and it is the ratio of lateral strain to the longitudinal strain. So here I have written two formula. One is with no sign and one is with negative sign. So both are okay. If we see mathematically, this holds good, but algebraically this holds good, because if longitudinal strain are positive, then lateral strain will be negative, because if we are going to elongate this beam or this member, the longitudinal strain is going to be positive, so it will be with plus sign, but the lateral strain will be negative, because there is the reduction in the cross section area of this member. So this will come with the negative sign. So if one is compressive, other will be tensile, and if one is tensile, other will be compressive in nature. So we use this negative sign here. So I hope you really enjoy this video. So stay connected. Thank you so much to watch this lesson till the end.